Hello, hello, good afternoon. This is Daniela Torres from ICLE, and we would like to welcome you to our webinar, Local Energy Generation Towards Smart Local Energy Communities. This is a webinar organized by the GrowSmarter project on EU Lighthouse City project. We would like to thank you very much for your participation, for your time. Just a quick introduction of how we operate the WebEx platform of this webinar. So first of all, please note that in the upper part of your screen, you will be able to expand your screen in order to see the presentations and the information in a better way. Secondly, please note that you are muted during the webinar to avoid any sound during the webinar itself. We will be recording the webinar, so we are aiming to have a good sound quality of the webinar. Then please, we encourage you to write us and provide us with any question you may have about the different presentations during the webinar. We will be, during the whole process, receiving your questions through the chat and the questions and answers component, so please don't hesitate to ask us anything that you may want. So now we are going to see the agenda for today. So just to remember the agenda for the day. So we are going to have now a welcome introduction from Alaya Solá from IREC Barcelona. Then we are going to have Christian Remankli from Rhine Energy representing the city of Cologne. Then we have Martin Brolin from Stockholm Energy that will share with us the case of the city of Stockholm. And finally, we will have Elena Maria Gilbert from Naturgy Barcelona that will share with us experience on this subject in the city of Barcelona. Then we are going to have a space for questions and discussion of 20 minutes. But as I said before, we encourage you to ask any questions along the webinar itself. So now I will pass the word to Alaya Solá, so she can do a good introduction of the GrowSmarter project in the context of this subject. Please, Alaya.
Okay, thank you, Daniela. I'll share my screen. Okay, so I guess everybody can see my screen. Good afternoon, everybody, and thank you, Daniela, for your introduction. My name is Alaya Solá, and I work in IREC, the Catalonia Institute for Energy Research, and we are based in Barcelona, as it was said. And one of our roles in the GrowSmarter project is to coordinate the low energy districts work package, in which work is being done with the topic of this webinar. So my aim today is to welcome you and to give you a short overview on what we do in this part of the project and introduce a specific topic we chose for today's webinar. So in brief, the main objective of the Low Energy Districts Work Package in GrowSmarter is the demonstration of smart solutions or energy efficient solutions to lower the environmental impact of the existing building stock in cities. And this is done mainly by tackling 3 different fields. We do building energy retrofitting to lower building energy demand. We also focus on empowerment of building users through information technologies to have an effect on user behavior. And finally, we focus on the deployment of local energy generation units and their integration with buildings. So all these measures have been implemented in real life within the GrowSmarter project for their technical demonstration, and their respective business models are also under validation phase nowadays. So today we choose to focus on sharing with you the experiences learned in GrowSmarter related to the demonstration of local energy generation technologies. And different solutions within this field have been demonstrated in each of the 3 lighthouse cities. They are Barcelona, Stockholm, and Cologne. And today we have 3 partners from each of the cities who will present us the smart solutions they have deployed in the project in their city. So we will have the opportunity of learning what do these solutions consist on, which stakeholders participated in the demonstration, how to evaluate them, and which business models are behind their deployment. So we really hope that these experiences will be inspiring for other stakeholders and cities. And having said that, I can only say thank you very much in advance for your attention, and we hope that you'll enjoy the webinar. So I'll leave the floor to the first partner from Cologne, I guess.
Can hear you, but as I said before, there's a noise. So we ask everybody please to mute their, especially the presenters, to mute your microphone so we can listen Christian better. Christian, can you speak now so we can listen?
Okay for you, or look for?
No, it's a little. It has a.
Now it's better? Are you still there?
Yes, Martin, can you listen to me?
Yeah, I can hear you.
Yeah, Martin, please, can you do the presentation now until Christian comes back? Is it possible?
Yeah, sure.
Can we change the agenda? Okay, thank you very much. So I will give you now the rights of presenters, okay? Please, thank you very much, and apologize for this sound issue. So now Martin is going to share with us their presentation from the city of Stockholm. Okay, Martin, you can share your screen, please. Martin?
Yeah?
Please, can you share your screen? Is it possible for you to share your screen with your presentation now?
Yeah, 1 second.
Yeah,
so,
thank you very much.
Share my screen, yeah?
Yes.
Let me know when you see it.
Yeah, now we can see, Martin. Thank you very much. Please go on.
Excellent. Thank you.
Gracias. Thank you.
So open district heating, so it's turning traditional consumers into suppliers. So it's heat recovery into district heating network. Brief around Stockholm Exergi. So it was formerly named Fortum Värme. We just changed it past year to Stockholm Exergi. We operate in Stockholm within the products district heating, district cooling, and electricity. We produce electricity from the CHP, like on the picture there, but we don't sell electricity to the end customers, only to Nord Pool. We have around 10,000 customers in Stockholm, and our main customers is facility owners. And then the facility owner provide the heat within the buildings. So we have above 10,000 customers, but we heat over 800 citizens. We have quite wide network of pipe for district heating and district cooling, over 2,800 kilometers. To give a feeling of that is if you put all the district heating pipes in one line, it will take you from Stockholm to Barcelona. As mentioned, Stockholm actually, we are equally owned by Fortum and the city of Stockholm. And our aim is that we will have all the production, district heating production from renewable or recovered energy no later than 2030. Today we're around 90%. And that's where this open district heating comes in, because it's a big possibility to have a heat source from a third party, a consumer, as part of the recovered energy. So I start with describing the open district heating. So what it is like you see on the picture there, we have a normal stream from the CHP out on the network and provide the heat to each building around the city. Open district heating turns this flow the other way around. So we have heat sources of waste heat from supermarkets, from data centers, from industry, and then we turn the flow so that the waste heat will go into the network. And then we utilize this infrastructure we have in the network to transfer this energy to the next demand of heat for another building. So this means that we have small-scale production scattered around the network in Stockholm. And this enables the customers to gain a revenue on this excess heat. Normally, they just get rid of the excess heat through the air, and it's also a cost mainly for pumps, etc., to get rid of this excess heat. Instead, they make a technical solution where they instead provide the heat into the network and they gain a revenue on it. Short background, we launched this to the market 2014, plus 20 suppliers today. And the past year, we recovered 113 gigawatt hours of heat into the network from third parties which have this excess heat, corresponding heating of around 31,000 apartments. And we have some other ongoing installation from other suppliers, which would add on another 100 gigawatt hours per year. So this, to give an understanding of the size, will mean about 3% of the total heat demand in Stockholm, district heating demand in Stockholm. So just to take this in a perspective, we start from all centralized production. Now we've taken the steps towards more third-party production via heat recovery, and this will come up to a figure around 3% today. Our main goal is 10%, and with that we can reach the goal, which I mentioned in the beginning, that we will have all energy from renewable or recovered energy. And in GrowSmarter project, we had 2 suppliers, one supermarket, Hemköp in Farsta, and one data center, Glestes in Västberga, which is connected to open district heating. If you have any questions, please go ahead as well.
Yeah, please continue, Martin. So far, we have not received any question in the chat, so please continue.
So connected to open district heating, we also have a next step of this, what we call the Stockholm data parks. So to compare these two, we can say that open district heating utilize existing waste heat sources in the city. With Stockholm data parks, we would like big data center to establish in Stockholm area. And for this, we have this cooperation together with City of Stockholm, together with Ellevio. Ellevio provides the electricity capacity in Stockholm, and also Stokab, who provides the fiber in Stockholm. And with this, we would like, instead of establishing data center and not taking care of the waste heat, we would like it to establish in Stockholm, and we can take care of the heat. And this comes to this picture showing what the industry of data center is moving. So it's starting from brown, what we call it, so that you have a fossil based electricity to the data center, and you will know that data center, they consume a lot of electricity, and they have a cooling machine because they have a lot of cooling need, and then the waste reaction into the air. Next step of the evaluation was that you utilize renewable electricity sources into the data center. That's where we are now. The next phase, what we would like to offer is that you take it to a green level. Of course, you have the renewable based electricity, but you also take care of the waste heat. So that will be the next phase in the data center industry. And some words regarding stakeholders in this project. The setup is quite straightforward and more or less plug and play, we can say. We have stakeholder is, of course, the open district heating supplier itself. So they have a waste heat source. We need to provide connection to the district heating network with pipes. And that's on the Stockholm Exergi responsibility. And for this, we have subcontractors to doing this work. And this is kind of our main process, since we're building pipes for our district heating customers as well. And then we have end consumers, of course, the customers from in a data center or a customer in a supermarket. And then we have the measuring, what is the amount of heat the supplier is providing into the network. That is on the Stockholm Exergi responsibility, and we provide this in each 5 minutes meter. So in ordinary district heating, we have per each hour, but for this we have implemented per each 5 minutes. And this because we need to have a better accuracy on this measuring, and we can also see if we have any issues with the temperatures or any issues with the heat pumps, etc. We can see this in real time or in each 5 minutes. Then we also have installation operators, subcontractors, which is doing the installation at the supplier site. So normally we have a standard case could look like we have a data center who has a cooling machine. Instead of that cooling machine, they install a heat pump, and the heat pump provides the cooling need to the data center, but it also provides the heat to the district heating network. So for this subcontractors and installation there, we have some companies who's providing this, but this is mainly on the supplier side of responsibility. The business model is that the supplier install, invest, and operate in the heat pump production. Some words regarding KPIs. So, for example, in this GrowSmarter project, the KPIs and the data we have collected to get a good evaluation of the project is that, of course, the cooling demand, the cooling demand for a data center or cooling demand for an industry or a supermarket. This is the core to a waste heat in all cases. They have a cooling demand, from that they get the waste heat. And for the projects in the GrowSmarter, we have what was the cooling demand before, what was the cooling demand after, as well as the electricity demand or electricity consumption. For a heat pump, the electricity consumption goes up some percent compared to the standard cooling machine, but you get the end product of a heat product. So that's an important factor in doing the main calculations. How much more electricity is driven due to this solution. And of course, we have the delivered heat and delivered heat temperature. So the suppliers, they get an income, a revenue from the delivered heat, and for that we have the Swedish crowns per megawatt hour. So it's energy, and also they need to deliver at the correct temperature, and the temperature is at the main part of the year 68 degrees, what we need into the network. And of course this is also an important and crucial parameter, since the heat we are purchasing from the supplier will go to another customer, so we cannot
molto.
Are you talking to me or no? Yeah, I continue. Also, we have some performance and COP on the heat pump is interesting, and the total energy demand and carbon footprint. Finally, regarding the business model, I think I mentioned more or less all of it. But we, as the utility company, we purchase the heat from the customer, the supplier, with the excess heat source. The excess heat is exported and delivered around the district heating network. The customer gain improved OPEX, but they also do an investment. So that's the business case, more or less. You're doing an investment in a heat pump, and then you get an cost turned into an OPEX, and this is paid back in 5 to 10 years, mainly standard-wise. And from Stockholm Exergi's perspective, we purchase recovered heat that would be more costly and less environmental friendly production. That is the core from our side. So we can avoid using oil or avoid using coal or those kind of fuels we use when we really need the most of the heat at the cold hours during the years. So then we can replace this with a heat recovered heat source. That is the main thing I would say. And you see the picture to the left is one illustration of how it looks for example Glesus case. Up to the right you have the data center. From there you get an excess heat around 20 to 30 degrees. Then we have two serial connected heat pumps who increase the temperature up to 68, deliver it out to the district heating network, supplied around the city, and we take in the return line from the district heating into the heat pumps, and the heat pumps also produces the cooling need to the data center. And up to the left you see the previous cooling solution where they had a cooling machine providing the cooling need to the data center, and then the excess heat was exhausted into the air. And for this case and and the often case is that the supplier has the cooling machine and the previous solution as a redundancy, as a backup. So if any issues with the heat pumps, the redundancy system goes on. So they also mainly get improved cooling capacity performance. I think that's all.
Okay.
Thank you very much.
Thank you very much, Martin. Very comprehensive presentation. I don't know if you have any questions now to our participants. You can please send the questions in the chat or in the questions and answer space. We will have anyway time for discussion about the different solutions at the end of the webinar. Martin, we don't have questions now, but hopefully by the end of the webinar we will have. So thank you very much for your presentation, and now we will give the floor to Christian. That hopefully his sound is already okay. So Christian, can you listen to us, Christian?
Yes, I can hear you. Can you hear me? Is the noise better?
Yes, now it's perfect. So I will now change the role to presenter. Please, Christian, go on.
Yes, thank you. First, I try to share my screen. I hope everybody can see my screen now.
It's loading, I think. Yes, we see a message. Perfect, yes. Thank you very much. Yes, we can see now. Gracias, Christian. Thanks. Go ahead.
So, okay, thank you. Good evening to everybody. My name is Christian Lemmerkli. I'm the project manager for the Work Package 2 Energy in Cologne, and I'm working at the Rhine Energy. Rhine Energy is a local energy supplier, one of the biggest in Germany. And now I'll give you a short overview over our measures in Cologne. So at first I give you an overview of all the systems and the involved partners here in Cologne, and then I give you an overview over our cloud-based energy management system. We call it in German Siedlungsmanagement. We can translate it in English to a settlement management system. On this system we also implemented a visualization, and I finished the presentation with the KPIs of this measure. So I'm starting. The project area is the Stegerwald Siedlung. It's an area on the right side of the Rhine River. In the project there are 16 buildings. You see the green buildings are already ready, and the last 4 buildings are under construction at the moment. 2 of these finished in February, and the last 2 buildings will be finished in March this year. We install on all buildings photovoltaic systems with around about 820 kilowatt peaks. 12 of the 16 PV systems are already ready. 2 buildings, we're still working on 2 buildings. We install the PV at the moment, and the last 2 we install at the moment the subconstruction. So 2 are ready in February, and the last 2 are ready in March this year. Also, we install heat pumps and district heating. So we install in consumption 41 heat pumps with a power of 492 kilowatts, and we also install a district heating with around about 270 kilowatts. Primarily the heat pumps are working, and for the peaks we have the district heating. The heat pumps are working with a maximum temperature of 55 degrees, and we need the peaks of minimum 60 degrees sometimes, and then the district heatings are helping the heat pumps for the peaks. Also, we install 10 battery cottages, and in these 10 battery cottages, they are outside of the houses. We included 16 battery storages with a power of 210 kilowatt or 655 kilowatt per hour. So every building has some systems. We have a battery storage, we have a PV system, we have a water heat pump, and we have a district heating. So we have four things that we control in each building. So to install all the measures, we are working together with some partners for the heating management settlement system. We're working together with Greencom Networks. With this partner, we implemented and created these intelligent software, and also we're working with another company that's called Hermes. They are programming all the systems on the PLC level, and we are also working together with some system manufacturers for the batteries and storage. For the heat pumps, we are working together with Fissmann, and the battery storage, we're working together with Hoppecare. And we have the overall project management to all these measures and systems in the settlement. So this Siedlungsmanagement, the cloud-based energy management system, is a self-learning system with an self-learning system. Yes, and this system take the forecast of the weather consumption and the weather and the consumption of the people who are living in the houses, and it's a self-learning system, and so when the system working longer and longer, it can be better every day for more information. So on this graphic, I think it's easy to see, better to see. In the middle, we have the Siedlungsmanagement, the energy system. It's a cloud system, and this cloud system has a connection in every house with an energy manager. That's a gateway, and this gateway, this energy manager, can also speak SPS. SPS is a standard in English,
PLC. Yeah.
PLC. Sorry, PLC. Sorry.
Yeah, it's fine. Yeah.
Yes, a TLC. Yes, and then we can speak with every system in every house. So we have a connection. Also, these cloud system become information from outside, like climatic data, and also we have a connection to our virtual power plant on the left side. And this power plant has also a connection to the stock market. And also we can control every system in every house perfect. Also we can give more information for visualization for the tenants or for companies or for someone else. And also we can control every system with one software. In the future, the software is be open for more systems. On the right side, you see we can also control another system, so we can control every system that can speak PLC, sorry. And also we can include mobility hubs or mobility services or something else. So the system is very open to integrate more systems and more solutions. On these, the system make an optimization based on the forecast of the energy production, and the consumption can be optimized. The system working fully automated and continually for the whole district. And you can set different goals. We set the goals to minimize the usage of the district heating, to minimize the grid supplies, and to minimize feed into the grid. So we would like to produce and use the energy local. And the goal is a very high autarky system in this settlement. In this project, the optimization is just carried out with an ecological focus. The system can also be switched into economic systems or into autarky or something else. But the main focus in this project is the ecological focus. So based on these optimization systems, we have flexibility, and this flexibility energy we can send it to our virtual power plant, and also we can send it to the spot market. Then based on the trading results, the schedules are sent to the energy manager in each building, and every system are working better and better after our specification that we sent. And also it's interesting, the system calculated all schedules for the next 36 hours every 50 minutes. So when the communication breaks up, all systems in the settlement has the schedules for the next 36 hours. And yes, so when we have a communication breakout, we have 36 hours time to send new information. And when the communication don't working after 36 hours, the system starting to work in an automatic modus. This automatic modus is not an optimization modus, but the energy supply is always safe in this settlement. So this one is the visualization of the settlement of the Siedlungsmanagement. You see, then you can see in every house how's the production, how's the consumption, how full are the battery storage, and you see all informations about your settlement and about your houses. And this one we do that the people who are living in this area, that they have a feeling, an overview, what happened with the energy in my settlement, in my houses. And yeah, that's the main goal, to see what happened. And then you can zoom into all the systems, and then you see what happened at the moment, how strong is the PV production, and what is how much power are working at the moment, the heat pumps or something else. Yes, you see a completely overview about the energy systems in your house. Yeah, that's over. You always see how full are the water tanks with hot water, and yes, you see everything what happened in your building live in real time. Yes, we also implemented some KPIs to the assets, the impact. We measured all the energy supplies by the local production unit. We also share a total renewable energy supplied of total local demand, and we share of external renewable energy supply of the total local demand. And also one of KPIs is the reduced CO2 emission in this settlement. That are our main KPIs. We have a lot of measure points in this area. So every 50 minutes we become thousands of informations and from the measure points, and must be analyzed and calculate and yes, send new schedules. And you see on the heat side we have the heat meters on the heat pumps. We know the high pressure temperature. We also measure heat meter district heating, yes, and so on. And on the electric side also we have information about every electric system in these settlements. Yes, we show this because to see that there are a lot of data are producing and sending to our system, and this system must be calculated every 50 minutes new new plans for the system, and it's a self-learning system. It's very complex and yes, very yeah, good. So this was my presentation, and please, when you have some questions, now.
Yeah, Christian, just one from here, Elena from Naturgy. Actually, I'm gonna present something similar, but I wanted to ask you about your participation in the market. That you say your your objective is ecological, so it's a focus on minimizing the emissions, but at the same time you're also participating into the market. How does, I mean, is that the same the same function? That you are minimizing your cost, I guess, because you're participating to the market, but then you are also minimizing the emissions at the same time. And as well, which market are you participating, and how does this? I mean, how does the economical viability works on that? If you can just give a number on how is the income from the market compared to all the other revenues.
Yes. So we have a connection to our spot market, because in the future we must have the possibility this connection. Also we have in the spot market green energy, and also we can charge our battery storage from the spot market with green energy, for example. Sometimes we have in the north of Germany a lot of wind energy, green energy, and in the Cologne the sun is not shining. And then we can buy on the spot market green energy and can charge our battery storage local, green and ecologically. Also the system is a self-learning system, and the goals of the GrowSmarter project are ecologically goals to reduce CO2 and produce energy local and use this energy local. But we can also switch the system into economically goals. My personal opinion is that there's no black and white. Also, there's a gray factor, a gray zone, that you can control all systems on one side ecological and on the other side also economical. But in the future we will see how good the system works, how good are the system optimize all systems local, and on these results we can develop the system more and more in the future.
Okay, thank you. Yeah, I know that you can be both on the economical and on the ecological, but I was thinking if you are doing a market participation not just into the daily market, but also in auxiliary services, and if you were aggregating demands to bid into the market, as you are calling it virtual power plant.
So what is the question? Yes, we can also switch it.
The question is if you are aggregating those flexibilities that you were talking about, and you are bidding into some auxiliary services into the market.
Yes, also
the
connection is in two-way. We can also sell green energy from the local production into the grid. So the system knows how much energy the tenants use at the moment, and when we produce more green energy that we can use, we can also sell it into the market green energy.
So are you receiving a signal from, I don't know, from the DCO, or when there is there is a problem in your network, are you receiving a signal so you can activate or you can use your flexibility to answer that?
Yes. Theoretically, yes. But this one we have to develop in the future. At the moment, we just have the connection to our virtual power plant, and the system are working local. But the connection, we developed the connection, and at first the optimization local is on focus, and in the future, when we see how much flexibility are possible, we can starting the virtual power plant and the spot market, and then that's the next step. Yes.
Okay.
Okay.
Thank you, Christian.
Yes. Thank you.
Thank you very much, Elena, for your questions. I don't know if we have any other question now.
Yes, please, Martin Molin, Stockholm.
Yes, Martin. Martin, please.
Hi, Christian. Very interesting. Well, one just question. You mentioned 16 buildings around. Are these optimized from energy manager on the perspective from each building, or are these buildings connected, for example, with a DC network, a microgrid, so to call, and it optimizes one big unit, or is it per building?
Yes, we have in every building we have one energy manager, and this energy manager are connecting with our Siedlungs management, with our system. We have not a separate grid in this settlement. And 60 buildings, just for information, and these 60 buildings are living 1,100 people. So it's a very big settlement.
Okay.
And in every building, they are living around. We have some small buildings with just 20 apartments, but we also have big houses with 60 or 80 apartments.
But theoretically, can you feed solar production from one building to another in a local network? No. Okay.
No, that's not possible. We have the unbundling law in Europe, and yes, we can make it bilancial. Sorry, I'm just looking for the English words. Yeah, we can make it on the balance sheet. So on the paper, yes, we can do it, but we cannot do transport energy from one battery storage to another battery storage. That's nothing. That's also not economically for us because we have to pay taxes for use the grid. And theoretically, on the paper with the balance sheet, it's possible, but not in real, not physical.
Okay, thank you.
Thank you.
Okay, thank you very much, Christian and Martin and Elena, for your questions. We don't have any questions now in the chat. Anyway, I will be collecting all the questions at the end of the presentation, but I would like now to give the floor to Elena to continue with the presentations. Elena from Naturgy, Spain, in Barcelona. So, Elena, please, if you can start your presentation, I will give you immediately the presenter rights, okay?
Yeah, thank you. But I should share my screen, or you're gonna share it?
No, you please,
Me?
directly,
Okay.
so you can control.
Okay.
Now you have the presenter rights.
Now it's okay?
Yes, we can see, you can see with your screen.
But just...
No.
Yeah. Can you see it, or because if I'm now?
Yeah, but we are seeing the managing screen of
okay.
of PowerPoint. So I think
Okay.
you have to double your screen. That's right.
Oh. Okay. I'll change. Can you give me again the because now I cannot see it. Can you give me again the rights?
Yes. No, you are.
Or just
the presenter.
remove it and then give it away, leave it again, because
Okay.
I put screen 1, but I think I should put
Yeah,
screen
okay.
2.
Don't
Sorry.
worry. No problem. Okay, we'll give it to you again. Presenter.
Okay, now it's okay, I think. Yeah. Okay, so thank you for joining the webinar, and I'll start with an overview of our company. I don't know if for those who are not familiar with Naturgy, but I think most of you are. We are a company vertically integrated in gas and electricity, and we are the largest in Spain and Latin America. We have actually generation in a lot of countries, but mainly in Latin America, and customers worldwide, mainly in Spain and Latin America as well. Okay, so the agenda for today, I'm gonna be explaining which is the energy management that we've done on our photovoltaic installations. Afterwards, we will answer the question on which stakeholders are involved and if their participation was the most effective one. I'll talk afterwards about how we are monitoring and how we are evaluating those projects and those installations, and I'll finalize with the replication of those measures and how is the business model built on those measures. So yeah, we don't have 800 kilowatt peak as as Christoph said, but we have 70 kilowatt peak in 3 different locations. 2 are completely finished, and the third one that it's actually in our headquarters in our offices is ongoing. Actually, is a huge pergola, and we have had a lot of troubles with the landscape department and the works department to achieve the licenses. So that's why it's still ongoing. But yeah, and the others they are commissioned and running, and we have one on a neighborhood community that is satisfying the consumption on the common sites of the building, and the other is on a tertiary building that it's a scholar center, and the third one will be here in the offices. And we have both photovoltaics and lithium-ion storage installed. And it's as the other rain energy speaker was explaining, we have smart energy. This slide will explain. We have a hardware software solution that has developed IREC, and it has different models which are self-learning on the consumption and on the generation, as well as like learning from the weather forecast to obtain the renewable generation, as well learning on the electricity prices and forecast it. And we have actually the same objectives. That's why I was asking. We are following 3 objectives: minimization of the cost, minimization of the peaks, as well as minimization of the emissions that our installations are producing. Yeah. So yeah, let's move to the stakeholders. Yeah, as I was saying, we've had a lot of troubles with the landscape department because in a urban environment, I don't know the experiences from Stockholm and Cologne, but in a urban environment like really dense city as Barcelona, we have a lot of like in tertiary buildings, in the rooftops, there are a lot of machinery that cannot be replaced by a photovoltaic, as well as the ordinance, like municipal ordinance, are not really aware or are not really encouraging those different uses of the rooftop. So we are actually running, or our office building is running, the first pilot for the municipality of a big of a big tertiary building installing a pergola, a photovoltaic pergola in the rooftop. And what I was seeing in here is that ideally all the permitting and licensing is is going on in parallel. Once the final design is completing and ongoing and in parallel with the tendering, because it can took more than planned. So the stakeholders in the whole value chain are from the beginning, from the client prospection side. There's building owners, facility managers, neighborhood communities. So we've talked to all of them to explain which are the benefits, as well as a really big important stakeholder is the regulatory body, not just not just the national, but also the regional and also the city one, as I was explaining. Afterwards, for the offer elaboration, we have subcontracted, not for the offer, sorry, the offer of elaboration, we are doing it with the design engineers, and then we subcontract the installation, and the manufacturers supply the battery and the photovoltaics and the electronic powers. And afterwards, for the permits and final design, we have all the regulatory, like landscape department and DCO and etc. And as well, a really important thing that we have had a lot of work with is safety coordinators, because in a tertiary building, in the rooftop, there's a lot of works going on with the maintenance staff, manufacturers, people working in the building. So we have to have a safety coordinator coordinating all those different professional activities into the rooftop. And then we build and we operate the operation as an energy service company. Okay, moving forward, to the equipment. We've done a really deep analysis on the different equipments existing on the market. For photovoltaics, we wanted to test innovative technologies. We've checked onto the dual cell technology, back contacts, bifacial cell technology, but we've gone to the dual cell because if the bifacial cell, it doesn't really make sense if in a pergola, because if you don't have the roof, like the roof in white, it doesn't really make sense, because you are taking profit of both sides of the model, and if you just have a model in horizontal, then you don't have you are not taking advantage of this technology. So we've gone through a lot of models, and we select the dual cell technology for this project in the headquarters of our office. Then inverters, we've mainly worked a lot with IREC to find out whether those different inverters were open. I mean, the protocol was open for them to integrate their EMS, their management system. So it was not a simple contact with Fronius or SMA. We had to go with their engineers and try to see how open they are and how we can actually control the variables on the battery. And finally, for the battery, we've tested some different lithium technologies. On one side, we have the iron phosphate. So I think it's mainly the most spread one, and we have installed it in the community, in the neighborhood community. But then we have the aluminum one that has the highest actually specific energy. So it means the highest kilowatt hour per kilogram. Sorry. But it has some drawbacks, like it cannot be installed in indoor. So, for example, here in our office, we couldn't install it in the basement, because so we have to install it in the rooftop, because it has highest specific energy, but the phosphate superior in terms of thermal stability. Okay, so that's all for manufacturers, and moving forward to KPIs. That's something that we are actually now working on, and we will. This is something from the web that we are monitoring. The small one in the neighborhood community, and yeah, we will be measuring mainly the self-consumption ratio. So how much energy are we providing with our solar and battery? And the savings will come mainly from the self-consumption ratio, but also as how we avoid maximum demand peaks, because it can have penalties related, and as well how the energy arbitrage impacts onto the economic savings. This is from one side, and the evaluation of emissions will be mainly coming from comparing which is the the renewable penetration on the national electricity mix. So which is the emission factor of the energy that we are consuming from the grid, and which is the emission factor that we as a prosumer are having, right? Because we have a load, we have in the left side, or I don't know which one, but like in the left side, you're seeing the national load for free or renewable, like free CO2 emissions generation, and in the other side, we have our installation curve, so the grid power and the self-consume energy. So comparing those two, we can see how much emissions we have avoided, right? And finally, for the business model side, as I was saying before, the rollout of photovoltaic installation at the urban scale is I mean, it's really compromised on the municipal ordinance, because they have to promote those kind of usage of the rooftop, and for the other side, we have to reduce the maintenance cost. It has to drop significantly, because it was a really significant variable or sensitive variable into our business models when we were analyzing the economic viability. And concerning the business models, as you see, is a straightforward model of an energy service company. We have the current situation without renewable. Afterwards, we have during the contract with the energy service company and the client, they are paying a monthly fee that in that case is paid by the community, that they are paying the same as before, but with the savings they are paying our investment, because we've done at year zero, we've done the investment, and afterwards the contract can be 5 or 10 years. After that contract, they have 25 years of photovoltaic generation that it's representing a yearly savings on electricity. So as you see it in the graph on the left, on the right, sorry. And and last, a more general view on if it's replicable or not, this business model. We say yes, and also, and especially because the new royal decree in Spain was released on December, and it will. I don't know the process of a new royal decree, but for now the self-consumption tax that applied before it has left behind, and so the economic viability is really affected by that, because there was a fee for kilowatt hour self-consume, and it doesn't apply anymore. And also the current government has has or is a knowledge that the collective self-consumption, so the share self-consumption, can be allowed, and this is gonna be regulated by each region in Spain. So we are actually waiting for the regulation from the Catalan government, and as I'm saying here, and as if you can see in the loads, yeah, it will impact a lot on the economic viability of solar projects, because you can really optimize the photovoltaic load curve with the synergies between loads from dwellings and the loads from the tertiary building on the basement, for example. So if a community is sharing the photovoltaics and also with the retail on the basement, it can be a really complementary synergy between them. So yeah, those two things, I guess, it will be the key for the replication of those kind of projects mainly in Spain. And yeah, that's all. Thank you so much. And if you have any questions, you can go ahead. Thanks.
Thank you very much, Elena. Very comprehensive presentation, very clear for the ones that we are not familiar with the Spanish market. So thank you very much. So now I would like to open the floor for questions until we get some questions from the participants. In the meantime, I have two questions. A couple of questions for Martin. Martin, if you can hear us. Martin, just our questions regarding the relationship with the ICT companies owning the data centers, because from experiences in other cities, excess heat capturing products in other cities of Europe, there's always a reluctancy of some companies of having any project on their data centers. So how did you convince them to participate in this project? How the companies wanted to show their interest in providing the excess heat to the network?
Yeah, we present this to the data centers with three main gains of this project. One is that they will actually help to do something good, to help do something renewable to the energy situation in Stockholm. And this has been quite vital point, because many of the suppliers have this on its advertising and have this on its web pages, etc. One thing is, of course, the financial part. So from turning a cooling cost to a cooling cost, but with an income on a plus side. So that's the business case perspective. And finally, there is this cooling performance, cooling capacity question as well. So if we present a business case which is good, but they can also have the existing cooling there as a redundancy, they double its capacity for cooling. And for data centers, this is always prior number one, to have it cooling 24/7. So this is also on the plus side.
Okay, thank you very much, Martin. Very, very interesting. I think that is a good insight of how to approach this kind of excess heat projects for data centers. And thank you very much for sharing this with us. Another question that we have is, what about during the assessing impact assessment? You mentioned that you gather a lot of data and information. So is that data available for the public or for the municipality? How do you handle these data generated from the systems themselves?
So, sorry, was that question for me as well, Martin? So what's your question said? How are we collecting and how can we present energy data from the
Yes.
heat recovery? Yeah.
Yes.
So what we have mainly it's the recovered heat, of course, the energy data there, and that's our own premises and on our own systems. So this is not open to the public. Of course, it can be done, but it's never been really a case of desire, so to say. But we use this data mainly for invoicing purposes and following up purposes. Then there is the operation data from the supplier side, and that is not today connected to each other, these systems. It's supplier's own system, and they provide it to us for this GrowSmarter project just for following up KPI purposes. There is, of course, some desires to develop this further to having like for the other cases being presented today. So this is the spot price for the heat we have right now. This is the production cost right now due to the electricity price, and from this we optimize a production. And from this you can compare the different kind of data sources and optimize it locally. Those kind of visions we have together with the suppliers. It's not in place today, but it might be soon.
Okay, thank you very much, Martin, for having these insights during the different projects of the Smart City project. This issue of data sharing and open data is taking more relevance every time. So it's very good that you have thinking about how to do this in the future. Thank you very much.
Thank you.
Elena, we have one question for you. Regarding the project implementation, you mentioned that you are working with the community and the neighborhood. How did you convince them of accepting this technology that sometimes is not, how can I say, is not familiar to them? Did you have any program in place, a particular program in place? You mentioned that you have several teams working in the field. Can you clarify a little how this was translated to the benefits of the system translated to the communities? I mean, the household owners or building owners.
Yeah, there was two kind of clients, as I explained. There's the neighborhood community. So we were mainly talking with the facility manager. So the company who is taking care of the managing of the building. And the second type of client is a tertiary. So we were talking mainly with the owners of the buildings, ¿vale? Okay. So for the first one, for the neighbors, it was mainly on the benefits was mainly a reduction of their bills, of their electricity bills, because they pay a monthly fee for all the common all the common expenses. And with the photovoltaic installation, there will be a decrease, because it was also accompanied by a replacement of the bulbs. So we replaced them for LED. So there was, it will be a significant savings coming from those measures into the community. That's and the monthly fee for each of the dwelling, it was not like a significant part of their payments.
Okay. Okay, thank you very much. Another question, Elena. You mentioned that your company has operations in different countries of Latin America also. Are you implementing this model in these cities? Are you taking this model? You mentioned at the end of your presentation the replication potential of these measures. Are you taking already this to other cities outside Europe?
Yes, actually, the one I know is for sure we have Chile Sol. So actually, they have a lot of like a lot of projects going on in Chile. I don't know exactly the cities. If you are interested, I can ask for, but I know that the regulatory environment was favorable, and they have a spin-off or a group that is called Chile Sol, and is deploying these services in there. In Europe, we know that we have also this service in Portugal for solar.
Okay.
And for sure, we are doing prospection also in different Latin America countries. But for sure, we are in Chile with solar.
Okay, thank you. Thank you very much, Elena. Thank you very much, Martin and Christian, for your time, your presentations. Alaya, also thank you for helping GrowSmarter project to coordinate this webinar. So now I will just give the floor to Alaya to finalize this webinar, just to everybody to know that this webinar has been recorded and all the presentations will be shared in the GrowSmarter webpage shortly. Please, Alaya.
Oh, okay. Thank you, Daniela. Well, I want to thank also our industrial partners for sharing their knowledge, their experience with us today. And well, just as a wrap up, as the participants could learn today, that the local energy generation in GrowSmarter is being promoted, and we are focusing from going from centralized systems to distributed energy, and also implementing smart management of renewables and integrating them with the grid. And I think it's interesting to say also today that as an outcome of the GrowSmarter project, this year we are producing a series of reports that will be published openly on our website, on GrowSmarter website. And in these reports we will share with everyone the outcome of the technical, economical evaluation of more than 20 measures that we have, for example, in the low energy districts work package, and also all the lessons learned through these last 4 years of project. We are now in the 5th and last year of the GrowSmarter project. So we want to encourage everyone to have a look on these reports that are going to come this year, because for sure they will have very valuable information. So thank you again for your participation, and we hope that you have learned a lot.
Thank you very much. Thank you very much.
Yes, thank you, Alaya.
Thank you.
Thank you very much. Thank you for your participation, and see you on the next webinar.
Okay.
Thank you very much.
Bye-bye.
Thank you.
Bye.
Bye.